In this question, we've got two solid structures shown. We're told in the question both are ionic solids, in which the ions have the same charges, but they have different radii. So looking at our diagram, we can see that the charges are the same from solid X and solid Y, but the radius of our particles on solid X, you can see each particle, if we compare them, is a lot bigger in solid X than in solid Y. So which solid contains ions with a greater radius? Solid X, those ions are bigger. What about the charge? Solid X and solid Y, we're told in the question, both have the same charge. They're both similar, so we're going to say equal. Next, we're asked about the lattice energy. So lattice energy is the energy needed to break apart an ionic compound. The stronger our ionic compound is held together, the higher lattice energy will be needed to break it apart. So looking at our solids and thinking about Coulomb's law, they have the same charge in both situations. However, solid Y, since they have a much smaller radius of particle, the distance between particles is a lot smaller, and according to Coulomb's law, a smaller distance means a bigger force because they're closer together. So according to Coulomb's law, solid Y would have a higher lattice energy. That means it would take more energy to break it apart. The reasons why is that its ions have a smaller radius and therefore a stronger Coulombic force of attraction, which is option 4 below. In this question, we have two diatomic molecules. That means molecules made of two atoms, shown in the image. If we look at molecule X and Y, we can see the sizes of our atoms in those molecules look the same in both molecule X and Y. But if we look at the bond, molecule X has 3 lines in its bond, showing that it's a triple bond or a third order bond, whereas molecule Y only has 2 lines between it, showing that it's a double covalent bond or a second order bond. So comparing our molecules, which molecule contains atoms that have a greater radius? They're actually equal. They both have similar radiuses of atoms. What about the bond? We can see molecule X has a third order bond, whereas molecule Y has a second order bond. So molecule X contains atoms that have a higher order bond between them. Okay, now we're going to think about the bond length and the bond energy. So bond length is based on 2 things. Firstly, there's the radius of our atoms. If we have a much bigger radius of atoms, the bond length, which is measured as the distance between the centers of the atoms, is going to be bigger just because the radius of the atoms themselves is bigger. However, in this case, the radius of the atoms is the same, so that's not going to affect our bond length. However, the order of the bond will affect it. The higher order bond has a stronger bond between it that pulls those atoms closer together. So the bond length actually goes down as bond order goes up. So as a result of that, molecule Y has a smaller bond order, so it will have a greater length. So which molecule has a greater bond length? That's going to be molecule Y. The reason is that it has a smaller bond order. What about the bond energy? That would be the energy required to separate these atoms from each other and break that bond between them. Now, bond energy, that is related to the bond order because a triple bond or a double bond is stronger than a single bond. And since it's stronger, it requires more energy to break it apart. So as the bond order increases, bond energy is going to increase. Those are related. So to find the highest bond energy, we want the highest bond order, which would be molecule X. The reason why is that it has a greater bond order.